Day 1, we're going to look at solving quadratic inequalities. Here's the intro problem. When Hannah, Lola, Tommy, Monica, or Molly kick a soccer ball in the air, the height h in feet of the ball after t seconds can be modeled by the quadratic function. The height over time, h of t, equals negative 16t squared plus 32t. So we've looked at problems before in the previous chapter with that negative 16 there, that's the gravity pulling down the ball. And then the 32 would be the initial velocity that the ball is kicked at. So first, let's draw a sketch of the flight of the ball. So if I have my axes here, this is x and this is y. If the ball starts at the ground, it's going to go up and then it's going to go down. That's not a great drawing here. The next question says, if you are asked how high the ball goes, what part of the quadratic is it asking you to find, and how could you find it? So again, we talked about this last chapter with the basketball problem. The highest the ball goes, if this is an upside down parabola, will be the vertex. And if I'm asking you how high it goes, well, that would be the h of t value or the y value. So h of t. So to do that, first we have to figure out the time it takes to reach the height. So this would be our t value, and then we'd have our h of t value here. And so to find the t value, it's like the x value. So we're going to say time is opposite b over 2a. So that's finding the x value, but here it's t for time. Opposite b over 2a will give us the time it takes to reach the maximum height. And so if we look at our quadratic function here, we know the a value is the number next to the t squared. The b value is next to the t. Here c would be 0 because there's not a c value there. All right, so let's plug in opposite b over 2a. Make this bigger here. All right, so opposite b will be negative 32 over 2 times a, which is negative 16. That's negative 32 over negative 32, which is 1. So after 1 second, that ball is going to reach its vertex, its highest point. To figure out the actual distance that it goes, that's h of t. Let's change to blue. So that's this right here. So we're going to find h of 1. After 1 second, how far is it in the air? Just plug in a 1 everywhere you see a t in the equation. So it's negative 16 times 1 squared plus 32 times 1. And so h of 1 will be 16. So at 16 feet, that's when it reaches maximum, or that is the maximum height of the soccer ball. So we can write that as a coordinate. Let me change colors again. So 116 would be the vertex. Let's write that neater here. 116. So there's the vertex, the highest point of the soccer ball. If you wanted to figure out when the ball comes back down and hits the ground, what part of the quadratic is it asking you to find, and how would you find it? So again, here's our graph. We found the vertex. This is the highest point. So when it hits the ground, that's the x-intercept, the 0, the root. And there's 2 of them, I should say, x-intercepts here and here. But we know that we kick it at 0, 0. So really, we're trying to find the second point here. Where does it hit the ground? Okay, so to find the zeros, you could factor it and find the zeros. We could graph it on our graphing calculator. We can use quadratic formula. Let's use quadratic formula here. And so we have, again, we need a, b, and c. So x equals opposite b. Again, here's a, b, and c, negative 16, 32, and 0. So x equals opposite b, so negative 32, plus or minus the square root of b squared, so 32 squared, minus 4ac. A is negative 16, and c is 0, all over 2a. Okay, figure out your 3 parts right here. So these 3 numbers I want to see calculated. So you have negative 32 plus or minus the square root of 32 squared. which is just 32. So really I should put 32 here. Because again, the squared and the square root here will cancel. All over negative 32. And we get two answers. Negative 32 plus 32 is 0. 0 divided by negative 32 is 0. So after 0 seconds. And then negative 32 minus 32 is negative 64. Divided by negative 32 is 2. So 2 seconds. So here's the time that we're looking at. After 2 seconds, it hits the ground again. So again, it starts at 0 seconds. We go up and then we go down. So 2 seconds, it hits the ground. You'll notice this just if you take our vertex, the 1 second, and double it, we get the 2 seconds. All right, so at 2 seconds, it hits the ground. And again, we can use quadratic formula because we set it equal to 0 and we solved. All right, D, if you wanted to figure out how long the ball is above 10 feet, what would that look like on your graph, and how would you solve for that? So now, again, let's switch colors. Let's use the orange. When is the ball above 10 feet? Okay, let's go back to our graph. And so let's say that this was like 10 feet right here. We're trying to figure out these 2 points and how long is it above 10 feet right there. Okay, so to do that, we can make this inequality. Negative 16 t squared minus, plus 32t. When is this greater than or above 10 feet? So just greater than 10 feet. Okay, so this is where it gets different than last chapter, because before we had when does it equal 0, when does it equal 10 feet, but now we're going to want to know when is it greater than 10 feet. So it says we can solve this using quadratic formula, but to use quadratic formula, what do we need on one side? Well, we need 0 on one side. So let's say we have negative 16t squared, sorry, the stylus doesn't work very well, plus 32t. And we're going to subtract 10 from each side, so here, do it with gray. We want to get 0 on one side, so I'm going to make this an equation and just say, all right, we're going to subtract. Well, we can leave it like this. Minus 10, when is that greater than 0? So there's the new part. Let's use quadratic formula and solve. Again, you would find your A, B, and C. So A is negative 16. Sorry, my stylus doesn't work very well. Okay, so A is negative 16, B is 32, and C is now negative 10. So that's the new part. We're going to plug into quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4 times A times C all over 2A. Figure out your 3 numbers here. So we get negative 32 plus or minus the square root of 384 all over negative 32. So then I'm going to split that up and get 2 answers. So one of my answers is at 0.39 seconds. And my other answer is at 1.61 seconds. So 2 answers here. And so if I were to draw the 2-dimensional, this so it says 1-dimensional, but 2-dimensionally, here's what it looked like. So our graph goes up and then it goes down. When is it above 10 feet? Well, at this point and this point. And there are 2 times here, so at 0.39 seconds. And here's my other one at 1.361. 61. So at these 2 times, that ball is above 10 feet. Now, what would this look like on a 1-dimensional number line? So here's the 1-dimensional part, just the line right here. So 1-dimensionally, at 0.39 seconds and at 1.61 seconds, we'll use open circles. And anywhere in between that, it's above 10 feet. And so that's what we're going to practice today. Tomorrow we'll look more at the 2-dimensional over here. But 1-dimensionally, can you find what interval of time that something is between, like above, for example, above 10 feet and so on? Okay, so here it is. How do you solve an inequality and graph it on a number line, a 1-dimensional number line? Okay, so here are the steps. erase this. You want to get 0 on one side. Why? So we can use quadratic formula. And then we use quadratic formula to find the zeros. And then we put it on a number line. We do have to pick a point, test, and shade. So let's, again, do these steps right here for this problem. So when is this quadratic right here less than 9? So again, if you were to graph this two-dimensionally, here's what we're looking at. When we solve something like this, it might look something like this. When is it less than 9? Okay. So this is what we're looking for. This is 9. At what interval of time? So right here is when is it less than 9. Okay, so let's try it. First step, get 0 on one side. So we'll subtract 9 from each side. And I'll write it over here. We have x squared plus 4x minus 5. When is that less than 0? Okay, so we get 0 on one side. Let's identify a, b, and c. So here a is 1, b is 4, c is negative 5. And we're going to plug into quadratic formula. X equals opposite b plus or minus the square root of b squared, so 4 squared, minus 4ac, all over 2a, so 2 times 1. We're going to circle our three numbers here. Okay, so x equals negative 4 plus or minus the square root of 36, which is 6, all over 2. Split it up, get your two answers. So we're going to get 1 and negative 5. All right, so what this means is on our one-dimensional number line, start with our lowest number at negative 5, go up to our highest number 1. We have a less than sign, and we learned last semester that that means an open circle. Now we have to figure out, do we shade between the lines or do we shade beyond the lines on the outside of the lines? Because again, what that means is if I draw my quadratic again, at negative 5 and at 1, there's zeros here. And we know this is a smiley face graph. And so we have to figure out, when is it less than or equal to 9? Is it going to be between or beyond on the outside of those lines right there? Okay, so you're going to pick a point, test, and shade. I'm just going to pick 0 because that's an easy point to pick. And where is 0? 0 is between. Okay, so here's 0. Let's test that in either equation. So you can do this equation or the original. I'll just plug into the original equation a 0 for every x. So if we do that, this is 0, this is 0. So is 4 less than 9? And yes, that's true. So wherever the 0 was, we're going to color here. Okay, so at any point in between here, this would be less than or equal to 9. So again, if we draw that picture, here's 9. It's going to be anything in here is less than or equal to 9, so between. Okay, so there's that new part, pick a point, test, and shade. It's going to either be in between your x-intercepts or beyond on the outside. So we'll do another example of where it's beyond, and this will be what we practiced today. Okay, so again, steps are get 0 on one side. Okay, so I'm going to rewrite that equation, add 21 to each side. Here's what it looks like. X squared minus 10x. And then minus 21, we'll add 21, greater than or equal to 0. Okay, so get 0 on one side. Find a, b, and c. A is 1, b is negative 10, c is 21. Plug into quadratic formula. X equals opposite b plus or minus the square root of b squared, negative 10 squared, minus 4ac, all over 2a. Circle our three numbers that we want. So x equals 10 plus or minus the square root. And I got 16, so I guess I didn't need that long of a radical sign, all over 2. We're going to find our two answers. So I get 7 and 3. All right, those are the x-intercepts, the 0. So if I'm going to graph this on a one-dimensional number line, start with my lowest number 3, highest number 7, and I'm going to use a closed dot because of this greater than or equal sign. And then we have to figure out, do we shade between the lines or beyond the lines? So again, if I were to graph this here, here's what our quadratic would look like. There's 3 and 7. And we want to know, when is this greater than or equal to negative 21? Okay, so to pick a point, test, and shade, again, I'm going to test 0. Here's 0 over here. And if it works, I'm going to shade the outside of the line. If it doesn't work, I'll shade the inside. So we'll go to our inequality. I'm just going to plug in a 0 for every x, so this turns into a 0. Is 0 greater than or equal to negative 21? And that is true. So it's true where 0 is on the outside of the line here, so I'm going to shade this way. So any number less than or equal to 3 or greater than or equal to 7, if you plug in the original inequality, this will be true. So that's when this quadratic will be greater than or equal to negative 21. So like on the outside right here. That's what we're testing for. Okay, so again, your steps are get 0 on one side, right here, find A, B, and C, find the x-intercepts, but the new part is put it on a number line. You're going to use a closed-in circle right here if there's an equal sign, otherwise an open circle, and pick a point, test, and shade. You're either going to shade between or beyond. Whoops, sorry. You're either going to shade between the lines, which we didn't do here, so here's between the lines, or beyond the lines. Tomorrow we'll practice this more and actually look at the two-dimensional graph.